Hi, this is Raphael Mudge. Welcome to Advanced Threat Tactics, a course on adversary simulations and red team operations. Advanced Threat Tactics is split up into 9 parts. First, we're going to cover how to stand up infrastructure for long-term operations and how to organize your infrastructure and how to organize your team. We're then going to talk about, in part 3, how to get a foothold in a modern enterprise with a targeted spear phishing campaign. Once we have that foothold, we're going to go on to parts 4 and 5 to focus on post-exploitation, privilege escalation, and how to harvest credentials and password hashes. We'll then talk about how to abuse trust relationships for lateral movement and how to tunnel different types of tools through a compromised system with Cobalt Strike. Finally, we'll wrap up this course by talking about 2 advanced but very important topics, and that's malleable command and control, which lets you change Cobalt Strike's indicators to look like another actor on the wire. And we're going to talk in great depth about evasion in a modern context with Cobalt Strike. Throughout this course, we're going to take advantage of several tools. Obviously, we're going to use Cobalt Strike. We're going to work from Kali Linux. Here and there, the Metasploit framework will make an appearance. We will also use offensive PowerShell capability, such as PowerSploit and PowerTools. And during the evasion lecture, I will show you how to take advantage of the Veil Evasion framework with Cobalt Strike as well. Okay, with that out of the way, let's go ahead and get started with part 1 of Advanced Threat Tactics, Operations. In this lecture, we're going to introduce Cobalt Strike and talk about some of its history and what it's built for. I will also talk about how to stand up a team server and connect a Cobalt Strike client to it. And we'll talk about Cobalt Strike's model for distributed operations. There, I will also give you best practices for organizing your Cobalt Strike team server infrastructure and organizing your team into different roles. Finally, we'll wrap up this lecture by talking about how Cobalt Strike handles logging and reporting for its adversary simulation and red team operation use cases. I mentioned before that Cobalt Strike is a platform for red team operations and adversary simulations. This thread of work has a history of about 5 years for me. My work with Cobalt Strike started with Armitage. Armitage is an open source front end for the Metasploit framework that allows a red team to collaborate. When I built Armitage, I made it for cyber defense exercises where college students were the training audience. I didn't have much intention to see it used in production. But the tool was well responded to, and some of the collaboration ideas seemed like they would actually be handy in other contexts. But there was a problem. The Metasploit framework by itself is not well suited for use against a mature enterprise. I thought I could correct some of these problems and build a product in the process that would support my continued work on these tools. And that led to Cobalt Strike. Cobalt Strike's model was to augment the Metasploit framework to execute targeted attacks and evade defenses. Okay? And I did this augmentation by building on top of Armitage. Cobalt Strike 2 came out in recognition of a market demand for what are called adversary simulations. These are basically red team operations that focus on emulating the actions of a specific actor. Cobalt Strike 2 took steps to address this need with its malleable C2 technology. And that's a technology that allows you to change Cobalt Strike's wire indicators to look like another actor. Cobalt Strike 2 also saw a shift towards low and slow post-exploitation with Cobalt Strike's beacon payload. I worked on Cobalt Strike 2 since July of 2014. Cobalt Strike 3 came out September 2015, and Cobalt Strike 3 is a standalone platform for red team operations and adversary simulations without direct dependency on the Metasploit framework. So what do I mean by red team operations and adversary simulations? Well, let's start with red team operations. My definition of red team operations is to emulate a representative actor to provide a holistic assessment of a security program, okay? Cobalt Strike supports red team operations by giving you the tools to stand up infrastructure for long-term operations, okay? Cobalt Strike is very unique in its capability to manage distributed infrastructure with one client, and you'll see that as we go through this course. Cobalt Strike also helps you execute a full scope type attack with its user-driven attacks and social engineering tools, okay? These tools are designed to help you get a foothold in a modern environment. Cobalt Strike also has several hooks to enable you to get past different types of defenses you'll encounter. Malleable C2 is one example of a Cobalt Strike evasion technology. Cobalt Strike also gives you the tools to work low and slow and conduct your post-exploitation and lateral movement actions. And you'll see Cobalt Strike's model for asynchronous post-exploitation and lateral movement as we go through this course. What about adversary simulations? An adversary simulation is an assessment that emulates an advanced threat actor to train security operations and incident response staff. You may be asking, how do I do that with Cobalt Strike? Well, you can use Malleable C2 to change the network indicators in Cobalt Strike's beacon payload to look like another actor. You can use Cobalt Strike's user-driven attacks or pair Cobalt Strike's beacon with an exploit from another toolset to approximate the actor's access vector. You can also use Cobalt Strike's flexibility to try and mimic the adversary's post-exploitation and lateral movement techniques. One of my favorite things to do is read threat intelligence reports, look at how the actor likes to work, and say, this is how I would do it with Cobalt Strike. Now, let's go into Cobalt Strike. First and foremost, Cobalt Strike is a collaboration tool. The software is distributed as a client that connects to a team server, okay? The Cobalt Strike client is the GUI, and the team server is software that can run on a headless server, and the team server is the part of Cobalt Strike that interacts with the target environment. The Cobalt Strike client does not directly talk to the target environment at all. It's also important to note that multiple Cobalt Strike clients may connect to a team server. How do you stand up the team server? Well, you need three pieces of information. First, what is the external IP address of the team server? You need to take note of that. Next, what is the shared password that you would like your teammates to use when they connect to the team server? Third, and this is optional, you need to decide which Malleable C2 profile you want to use for that particular team server. Once you know the answer to those three questions, go ahead and start the team server with the team server script included in the Linux distribution of Cobalt Strike. It's very important to note that the Cobalt Strike team server only runs on Linux. It does not run on Mac OS X. It does not run on Windows. To start the team server, I need to know my IP address, in this case 192.168.1.2, and I need a password for my team to use. So we use the password password. To start the team server, I'm going to use the team server script. Now, optionally, if I want to use a Malleable C2 profile, I can do that as well, okay? But we'll just stick with the default profile for now. So there we go. The team server is now up and running. Now, when you start the Cobalt Strike client, and you may start the Cobalt Strike client on Windows, Linux, or Mac OS X, you're going to tell it how to connect to the team server. You're going to give it the team server's address, the port, the user field is your nickname or handle, and you're going to give it the password for that team server. Press connect, and the Cobalt Strike client will connect to the team server. Let's go to the Cobalt Strike folder. Let's run Cobalt Strike. That's /Cobalt Strike. And here's the connect dialog to connect to a server. Okay, let's go ahead and put our nickname in the user field. In my case, it'll be Rafi. Why not? And we'll put in the password. Press connect. We're going to be prompted with the team server's fingerprint. This is a hash of the SSL cert, and it's presented before any authentication information is sent. We can see that these two values do indeed match, so nobody's trying to man-in-the-middle us. Good. Let's hit yes, and there we are. We're now connected to the Cobalt Strike team server. Let's bring one more client into this. Here's a Windows system. I'm going to go to the Cobalt Strike server, double-click cobaltstrike.exe, and you can see I'm being asked where I want to connect to. Let's do new profile, and we'll put in the IP address of the team server, put in my nickname, and my password. Let's press connect. We're being prompted. It's cool. And here we are. The Windows client is now on the team server as well. When you're connected to the team server, you can use the event log like a chat room. So you can send messages to your teammates. You can actually do actions, things like /me dances. So it's a lot like Internet Relay Chat if you're familiar with that. Okay. When you're connected to the team server, each member of your team can see the same sessions, they can see the same data in Cobalt Strike's data model, and they can pull down the same information gathered during post-exploitation. Now that we've seen how to connect to a Cobalt Strike team server, let's take it a step further. Cobalt Strike is not designed to conduct your engagement from one team server. Cobalt Strike is designed for you to use multiple team servers during one engagement. You may be asking, why? Simple answer, operational security. If one team server gets caught, you do not want that to destroy and end your whole engagement. You do not want one team server getting caught to unravel the rest of your infrastructure. This is why Cobalt Strike supports multiple team servers. How to use multiple team servers with Cobalt Strike? Easy. Go to Cobalt Strike, New Connection, and you will see the Cobalt Strike Connect dialog. Choose the team server that you want to connect to, and when you're connected, a bar will show up at the bottom of the Cobalt Strike window that allows you to switch between Cobalt Strike team servers. Right-click on a button and go to Rename to rename the button to something that indicates that team server's purpose. If you want to close a connection, just go to Cobalt Strike Close, and the current connection will close. And that's all there is to it mechanically. Let's go to Cobalt Strike, New Connection, and I'm going to connect to another team server. I'm going to connect to ads.losenolove.com, and we'll put in the password for that server. Press connect. We get the fingerprint, looks good, and here I am on a second team server. You can see that I can flip back and forth between these team servers by clicking the button at the bottom of the Cobalt Strike window. Now let's go on to a third server. A shortcut, instead of Cobalt Strike New Connection, is to press plus, and now we can connect to our other server. Notice that each time we connect to a server, Cobalt Strike keeps track of the connection information as a profile. So let's put in the password, press connect, and here we go. I am now connected to 3 different team servers with Cobalt Strike. If I want to, I can rename them. I call this one localhost. I can call this one EC2 ads, and right-click, rename EC2 malware C2. So that's how you rename servers with Cobalt Strike. And if you want to disconnect from one, just go Cobalt Strike, close, and here you can see we are now disconnected from the team server. If you press close, the button will go away, and you can reconnect to it again, no problem. Okay? So that's how you connect to multiple team servers with Cobalt Strike. Okay, now that we understand the mechanics of Cobalt Strike's infrastructure, let's talk about best practices. When you stand up multiple team servers, I recommend you have 3 tiers of servers. The first tier are what we call staging servers. A staging server is a server that hosts your client-side attacks and receives initial callbacks. These are also the servers you do your initial post-exploitation actions on, primarily privilege escalation, your initial lateral movement, and installing any persistence you want to install. You should expect that these servers will get caught very quickly, okay? The servers that you actually operate from and achieve your objectives from are post-exploitation servers. These are the servers where you do your post-exploitation and lateral movement. The servers that you should be very protective of are what we call long-haul servers. These are the servers to receive low and slow persistent callbacks that you've installed at strategic points in your target's network. You should only use long-haul servers to pass accesses to post-exploitation servers as needed. Now, let's talk about scaling red team operations. And scaling red team operations might mean multiple target networks over a long period of time, or one target network supporting multiple engagements over a long period of time. Either way, the model is the same. You want to have target cells for each target network or engagement. Target cell is responsible for objectives on a specific target or objectives for a specific engagement. The target cell's job is to gain access, conduct post-exploitation, and spread laterally. They also want to maintain local infrastructure for those tasks. And by local infrastructure, I mean their own staging servers, their own post-exploitation servers, and their own long-haul servers for their persistence, okay? As much as possible, target cells want to be self-sufficient for their engagement. But it's not realistic to assume that a target cell will operate without getting caught. To manage low and slow accesses across all of your targets over a long period of time, you want a global access management cell. The job of the global access management cell is to hold on to strategic accesses for all of your networks, okay, over a long period of time. This access management cell may try to gain its own access, but ideally it receives access from target cells. Now, the best access is the access that you actually never act from and never use. The access management cell should be there as a fallback or as a cell to seed a target cell when they need to perform some sort of objective, okay? So the job of the access management cell is to pass access to target cells as needed. The other thing the access management cell does is maintain global infrastructure for persistent callbacks. So these are the folks who stand up team servers, they stand up redirectors, they register or buy domains, and they take all the necessary steps to make sure you have good, healthy infrastructure for maintaining long-term access. Now, let's talk about team roles. No big surprise, the team roles are very similar to how I stratify the different types of Cobalt Strike infrastructure. On your team, you want members of your team devoted to access. Their job is to get in, potentially through targeted spearphishing attacks, or, if your rules of engagement allow it, very controlled, very careful waterholing attacks. The access team is also responsible for trying to expand your foothold, okay, and spread laterally into a network to key places. The post-exploitation members of your team are responsible for searching for information. They're responsible for user exploitation. These are the folks that will ultimately take action on whatever objectives you as the red team have. On your team, you also want a local access manager. My friends and I refer to access managers as Shell Sherpas. We call them Shell Sherpas because their job is to herd and protect the shells. Access managers manage callbacks, okay? So any callbacks coming in to your long-term infrastructure are managed by the access manager. They also set up infrastructure for your teammates to use. The access manager should also be the person designing your persistence scheme. Persistence is an art. It requires very careful testing. You don't want each of your teammates trying to become experts in how to do this. It's better to let a specialized cell in your team craft something, build a script, and give it to your other teammates to use. Now that you know about some of Cobalt Strike's best practices for distributed operations and team roles, let's talk about something else that's also very important, and that's logging and reporting. Cobalt Strike logs everything on the team server. All of the logs are stored in the logs folder in the same directory where you started the team server from, okay? And here's a snapshot of some of those log files. These files are logs for individual beacon sessions. They're organized by date, in this case September 11th, 2015, and target, and individual beacon session. The number in the log file name is the beacon session ID. Keystrokes and screenshots are saved as well, and they're organized by date and host also. The screenshot's name is screen_time. So in this case, it's 1:53 and 21 seconds, so almost 2 a.m. And then session ID is the last number. Something else important to note. Cobalt Strike session log files give you attribution for each task. So the input block is the command that was run and the operator that issued the command, along with a date and timestamp. The Cobalt Strike logs also give you Cobalt Strike's narrative understanding of the task that was issued to it. Cobalt Strike also takes steps to log indicators that a blue team may be able to observe in the log files as well. So here we have the MD5 hash of a file put on a target. You can see the check-in times for each of the beacon sessions and the output that was provided by each beacon as well. Cobalt Strike's reporting is designed to train and help blue teams. Go to the reporting menu to see Cobalt Strike's different reporting options. A few things I'd like to point out in general. Cobalt Strike exports reports as PDF files and MS Word documents. What's really cool is either format you choose, the report will look the same. The fidelity between the two formats is, in my opinion, amazing. Cobalt Strike also allows you to change the logo in the reports. I recommend that you do that. Go to Cobalt Strike Preferences Reporting. You may also load custom reports into Cobalt Strike. These reports are written in Cobalt Strike's aggressor script language. These reports allow you to take the data available to Cobalt Strike and turn them into whatever kind of report you want. The reports you load will be available in the reporting menu as well. Here's something else that's very novel. I mentioned before that Cobalt Strike is designed to work with multiple team servers, okay? No one server has the entire story for the whole engagement. When you generate a report, Cobalt Strike merges the data from all those team servers into one data model. That merged data model is the model Cobalt Strike uses to generate its reports. Cobalt Strike also takes steps to correct the clock for different time-stamped events between all the different team servers. So when you generate an activity timeline from multiple team servers, even if there's some clock skew, the Cobalt Strike reports will come out sane. Now, let's go through some of the reports. One of my favorite reports is Cobalt Strike's Indicators of Compromise report. This report is designed to resemble the appendix in a threat intelligence report. The Indicators of Compromise report gives you a sample of Cobalt Strike's beacon traffic. This traffic sample is derived from the Malleable C2 profile you load. Here, I have a profile loaded to look like the Havex Trojan, and we get a very realistic looking traffic sample. The Indicators of Compromise report also gives you all the file hashes that you uploaded to different targets during the engagement. And it provides domains and IP addresses used amongst your team servers for command and control. By design, this report gives no context. It's meant to be a teaser to hand to a blue team in the middle of the engagement to hurry up the detection phase if it's not happening quickly enough. It's also a handy reference to help with deconfliction as well. Cobalt Strike's activity report gives you a merged timeline of all activity that took place during the engagement. You get a date and timestamp, you get the host where an activity took place from, you get the PID of where the activity took place from, and the user that process was running as. If you see a star next to the username, it means that the process was running in a high integrity or administrator level context. The sessions report takes this a step further. The sessions report breaks down each beacon session by communication path, so you can actually see the path an individual beacon took to get to the internet. This is really important because Cobalt Strike 3 enables very complex pivoting by chaining beacons together over named pipes. You also get a timeline of all activity for that individual beacon session. The sessions report also gives you indicators for individual beacon sessions as well. For example, if you upload a file to a system, the sessions report will show the file hash and the date and time that file hash was generated. You can very easily correlate that date and time to the action that the operator took. So in summary, I introduced you to Cobalt Strike, a platform for red team operations and adversary simulations. I gave you the history of the project as well. I took you through how to stand up a team server and how to connect to it. We also talked about Cobalt Strike's model for distributed operations. We wrapped up by talking about Cobalt Strike's tools for logging and reporting. This concludes part 1 of Advanced Threat Tactics.